So now here we are assessing third-party software risk without source code. Your speaker, this very serious-looking man on your screen is me. My name is Josh Knox, and I just go by Knox. I'm a senior cyber strategist here at ReversingLabs, and I'm a big geek and really love all this stuff. So we're going to have a lot of fun today. ReversingLabs at a glance. If you are not familiar with ReversingLabs, let me explain a little bit here. We have the largest searchable threat repository in the business, over 40 billion examples that we can search over. We have 8x, that's 8x larger than the nearest competitor for our threat repository. And we are under the hood in over 60 cybersecurity companies. So you see this number over here, the 60. I want you to understand, because the very next number here says that we analyze 20 million files daily. And if you don't understand that we are under the hood in over 60 cybersecurity tools, then you'll question that number and you'll say, how are you guys scanning 20 million a day? Well, that's because a lot of big cybersecurity companies that you know and love, they don't build their own complex binary system to be able to do reputation on files. They just outsource it to us. So that's why we have so many files coming through, and that's why our repository is so big. We have the fastest file deconstruction, 3 million malware identified daily. We've got over 300 employees. We're in Boston and Croatia. Those are the two locations for our headquarters. All right, enough about that. Let's move on now. Okay, so this is what we're going to be talking about today. So a lot of times we think of software as a black box. We think of it as something that is just a complete little, object. This is a binary, your .exe if you're on a Windows machine. But it is so much more than that. There are, and I love this illustration that we use with the little boxes inside the big box, because your binaries are made up of different components. And there are sometimes proprietary components. Those are things that your people write, or the software company that you're buying the software from creates. There is commercial software that people buy licenses to include their software in another piece of software. There's open source software, which we all know about, right? You go out, you don't build software from scratch. No one does that. They go out and they bring in third-party libraries to be able to speed creating that software that they're making. So the finished binary includes all that open source software as well. And then there are just straight up artifacts. Sometimes there's data that has to be inside that binary. Sometimes there's metadata that has to be in the binary. So there's also artifacts that live inside those binaries. So we're going to talk about this black box of commercial software. We're going to look at gaps in existing TPRM methods. And we're going to look at how Spectra Assure delivers and the workflows of that. We're going to do a demo, and then we'll let you ask some questions. So commercial software is a big attack surface. When you look at this slide and you see these names on here, we all remember SolarWinds. It was the Christmas that was terrible. So if you don't remember how that works, the bad guys were inside SolarWinds and they waited until Christmas break, and then they sprung their trap because they knew everyone would be gone for holiday. And it was bad. MoveIt, if you had MoveIt in your environment, it was a file transfer tool. It was terrible because they were able to get remote code execution off the UI and break in. And that was a software supply chain attack. Kaseya, they were infiltrated. 3CX, their 3CX supply chain attack was very interesting because the delivery of the updates is what was compromised. You know how on your Windows machine, you've got that little tray in the corner and you click on it and it's like, oh, we're doing automatic updates to protect you. Yeah, well, in this case, the automatic updates infected you. So that was what happened with 3CX. So we have to be aware. We can't just trust the vendors that everything's fine. We have to also, as organizations, do our due diligence to make sure that the software that we're putting in our organizations is safe to be putting into our organizations. So the classic third-party risk management here is like this. You say, hey, how are we going to vet and make sure that this third-party software is safe? Well, let's send a questionnaire. We have a questionnaire we're going to give to the vendor, and they're going to fill it out. And as you can see here, well, that's manual. It's prone to error. It's point in time. Who knows how old the answers are in that questionnaire? Who knows that the person even answering the questionnaire even really knows the real answers? That's another problem. The vendor may provide an SBOM, and SBOMs are great, but SBOMs are just an ingredient list. An SBOM just tells you all the things that were put into that binary to create it. It doesn't give you CVEs from those pieces of those components. It's not telling you any other risk insights about the software, which we'll talk about more here in a little bit. Some of those risk problems are things like hardening or tampering, or if there were secrets, lots of different things that just go way beyond what the SBOM can tell you. A security rating. Again, a security rating doesn't give insights into the software and is only as good as when it was created. So again, new versions come out, patches come out, this becomes old very quickly. Pen testing. Pen testing is costly and is unscalable. So if you have a software product that you are looking at buying, and let's say that you have 10,000 endpoints and you're looking at a $500,000 license with some very large software company to be able to buy these licenses for your endpoints, and you pay a pen testing company to look at that software, and what are they going to do? They're probably going to fuzz it. And what that means is they're going to try to attack it with lots of junk and hit it and try to break it from a lot of different directions. But they're still not looking inside it. And they're still not understanding the composition of that binary itself. Sandboxing. The other thing that people do is they say, well, we're just going to take that binary, we're going to detonate it in a sandbox, and then we'll know what we need to know. Well, the problem with that is that a lot of times the bad guys know that that's what you're going to do. So a lot of times the malware can even tell when it's in a sandbox. It knows it's in a sandbox, and so it won't detonate because it knows that it's in a sandbox. Also, let's say that it's an installer, and this software needs to be installed, and so you have to click, and you got to pick a file location, and you have to maybe put in a license before it even works. So if you try to run that in a sandbox, the installer opens, but nothing happens because it's just automated. So the only way that would work is if you actually had a person who was dedicated to clicking through that sandbox and making sure that it worked and went through that whole process perfectly. All right, let's move on. So let's talk about ReversingLabs. We're fast. We don't need source code. We're going to look just at the binary. We're going to do complex binary analysis. We're going to deconstruct the binary so that we look at all the components. We deconstruct it recursively. We go far beyond the SBOM. We're looking for malware. We're looking for signs of tampering. We're looking for vulnerabilities. So we are going to show you the CVEs that we find. We're looking for hardening. Now, the hardening is making sure that this software meets good software standards, that if it's a C program, for instance, they haven't left all their debugging markers behind. If it's also a Windows program, that they actually have the memory randomization turned on, and that they haven't turned off security features to make it easier to write the software. Those are things that you're not going to see unless you run it through this kind of binary analysis. Secrets, have your developers inadvertently left secrets inside your software and let it out there and leaked it for the world. And then licensing. Does this software has it used software that it shouldn't have used that will leave it open to a lawsuit or some other legal action because they are using it in an improper way? So when I say that we deconstruct these larger packages, this is what I mean. Especially if you think about an installer. An installer is going to have several pieces inside it. So we have the original binary here, and we keep going with this cube analogy because the cube analogy really helps us think about these things as components. So you've got the original software binary. It then gets deconstructed recursively. And when we say that, it's just think of like a nesting doll, right? You just keep opening up and getting smaller and smaller on the inside. And so we find this package inside the original. Then we look at this package and we're like, okay, this package contains this package, which contains all of these little packages. And we're just going to recursively unpack that binary all the way down. And that's how we're able to find the open source that's inside and all the commercial software that's inside, et cetera. And we'll see that when we get to the demo. All right, so let's talk about some use cases here and exactly how this would work. So in this case, let's again go back to that idea that you are going to, you've got 5,000. I don't remember how many endpoints I said before, but we're going to say 5,000. 5,000 endpoints, and you are in charge of deploying some kind of software that's going to go out to all 5,000 of these endpoints. And you talk to the software vendor about the software, and of course they're going to say, "Oh yeah, our software is amazing; it's the best." But you know that you are responsible for all those endpoints, and you do not want those endpoints to be compromised. You don't want to be pushing software on them that is going to hurt you in the long run. So what you do is we have the software, we get the software from the vendor, whether it's new, whether this is the installer, or it's updated or a patched version of it, because we can continually scan it, right? So even after you install it, let's say you make the decision to buy this software, you're still going to need to scan it continually. You need to scan it continually just because there are new threats that are emerging that you need to scan for those new threats. And secondly, if there's an update or a patch, the binary has changed, and therefore it needs to be scanned again, and you need to make sure that it still meets your approval before you deploy it out. So here's your team. Your team here that is doing the third-party risk management is going to upload the file to Spectra Assure. Now, by the way, you can do this directly in the console, or you could use an API, or we even have a command line tool if you're producing software. But however you do it, you upload the file into Spectra Assure. Once the file is there, it's going to be analyzed. It's going to be broken down into those components. We're going to look for the things that we've already talked about: the malware, the tampering, the vulnerabilities, the hardening, the licensing, the secrets. And then based on the report that comes back, you now can make an educated decision about your risk appetite and whether you feel like this is a piece of software that you would want in your environment. And so maybe it comes back with some caution, and you contact the vendor to say, "Hey, we found some problems with your software. What's your roadmap? What are you going to do to fix this? How soon can we expect an update?" And you can see here there's a line that goes back, this securely share report, because we have shareable reports. Once the report is created, you can create a link and send that link back to the vendor and say, "Hey, here's the report we got. We would like to have a talk about this." Also, you may get it back and it may just be beautiful, pristine code and everything is fine. Normally it's not beautiful and pristine, but at the very least, it at least meets your risk appetite and you are able to approve it. And then you're able to deploy it out into your environment. You've got a nice paper trail. You've done, you've dotted your I's and crossed your T's, and everybody feels good about this thing that we've deployed because we've actually done our due diligence. All right. So here's our next use case. So now let's say you already have several pieces of software in your environment. You've been running these pieces of software through Spectra Assure, and you have been doing your regular updates and scanning every time they come through, or on time intervals, or however you've got that set up within your organization. Now, a new, one of the big supply chain attacks comes to light. And in this case, we have like Log4j or XZ. And by the way, in each of those cases with Log4j and XZ, those were both components. You don't just install Log4j on a machine, or you don't just install XZ on a machine. In the case of XZ, it came built into an operating system. And in the case of Log4j, it was usually buried deep inside a Java application. And most of the time, people didn't even know that it was a part of the application because of reasons like we've talked about already with the recursive unpacking. It was buried deep inside those components, and they didn't even know it was there. What we allow you to do is to be able to go into Spectra Assure, and when one of these comes to light, you'll be able to know immediately. It will begin alerting, for one thing, to tell you that oh no, look, there's little red dots, because inside this application we see this thing that has been revealed to the world, and it is now a known bad library or attack of some kind. And now, if it already exists in your organization, you can either review your SBOMs and check for yourself manually, or you're going to start seeing these red lights popping up saying, hey, you got problems, and this application is vulnerable to this compromise that has come out. And then again, same thing. You can either mitigate, or if there is not, you could deactivate the program. Again, contact the vendor to find out if they have a patch, etc. All right. So now we're going to go into the demo. Actually, before we go into the demo, I'm going to scroll up, because I teased you earlier that there was going to be a use case that I wanted to. Oh, I didn't mean to do that right there. Yes, we do review patches in the sense that we can look at the patch, and we can also, if you run the patch and then upload the binary that has been patched, you can run it as well. So you could run the patch, or you could run the binary that's been patched. If it were me, and you're asking me personally, I would say run the patch and add the patch somewhere safely, and then upload the patched binary, and then from there, go ahead and check that. Or many times the vendor has the already patched binary available for you to download, and then you can upload it and check it. So here's that use case that I was teasing you about earlier, and I want to know if any of you have this in your environment. Another use case that I've run across is sometimes organizations have legacy software. Let's say that you've bought a piece of equipment. This is usually how this works. And the equipment requires a Windows 7 machine. We won't go back to XP, although I have seen situations that are that bad. But this machine requires Windows 7, and it requires this particular software to be able to control the machine, and no one is updating it anymore. And you own this machine in your business, and the machine works fine, it's doing the job, and you've got this little Windows 7 machine sitting next to the, this physical machine, and it has to control it. And it's in your environment, and you can't do anything about it. This feels like a perfect opportunity for Spectra Assure, because you need to scan that binary that's running on that Windows 7 machine. And you may need to even scan some other Windows 7 binaries, depending on, again, your risk appetite. The scenario I came up with is, let's say that this old software has a user interface, and the user interface has some kind of vulnerability inside it. In other words, like there's a field, and if I put a certain key string in the field, I can get remote code execution, or maybe you can connect to it remotely, so you can remotely control the machine. And if you send this key string to the machine, you can do bad things. Well, if you know that, if you've scanned the machine with Spectra Assure, you've scanned that binary, is what I'm saying, and you know that that is a vulnerability that exists, that allows you as an organization to create mitigating controls around that machine. So in that particular case, if it was a network machine that had the problem of having this vulnerability that could come over the network, you could put a proxy around that machine that filters out that bad string and says, nope, that bad string cannot go through to this machine. So you have a mini firewall basically blocking it. And now, again, as a company that would have compliance, you have a paper trail. We scanned this machine. We can't update it. It's mission critical, but because we've scanned it, we know the problems. We've created mitigating controls around it, and now it fits into the risk appetite of the organization. Oh, I like that. I got some fireworks there. So you tell me in the chat if that is one that you've seen before, or if yeah. So if you've seen that before, let me know. If not, it's fine. That was just a use case that I thought of. All right, now we'll get into the demo. All right, so this is the Spectra Assure console. And when we get in here, we're greeted with the console itself. You can have different organizations. So if you have more than one department that is using Spectra Assure, you can assign different organizations. You can have a group, a different group inside your organizations for being able to have, RBAC, role-based access control for your users. Some read-only, some with the ability to make other changes. I have uploaded several little pieces of software here, and we are going to look at Splunk, because the reason I want to look at Splunk is because I feel like this is a common installer that a company might be looking at, because maybe they're thinking about adding Splunk to their environment. So before we even click on it, if we look at it here, we can see here's Splunk. We can see the duration. It took 4 minutes to analyze this. It's a deb file because it's an installer for Linux. And the reason, by the way, that it took 4 minutes is because it's an installer. And so I am sure that there are probably thousands of little files inside this installer. And the number of files inside it ends up making it larger, because obviously it has to recursively continue to unpack all these things. And it was almost half a gig. Well, it was over half a gig on its own. We see here there's an SBOM. We found 324 components inside this installer. We were able to verify 218 of those components, which, if my math is correct, that's a little over 100 that were not able to be verified as we went through this. Whoops. And here we go. So here is, if you click on the Splunk, on that installer, this is what you get. You get to come to this screen. We see here that it is failing. It is not, you're shooting for level 5. Level 5 is where we are trying to get to. And level 1 is the lowest level of security. It does reach level 1, so that's good. But if it were to reach, for it to reach level 2, we would have to fix 5 issues. And if I hold over level 2 here, it shows me here are the 5 issues that would need to be fixed in order to reach level 2. And in this case, it is simply some CVEs. So let's go ahead and take a look at those. If we click on the vulnerabilities here, I'm gonna click on it this way and go right here. And here we go. And here are these vulnerabilities that we've found. And there we go. So we've got, we have files here that are showing these vulnerabilities. And I'm going to actually go back through the triage. Here we go, because this is what I want to show you. So if we go this direction, by the way, there's many directions to get to the same place, obviously, inside the console as you keep learning more about it. So if you click on the vulnerabilities here, we're going to start with the highest vulnerabilities. Obviously, the ones that are the most important. This is a 9.8, another 9.8. One of the things I love that we do is not only do we show you the vulnerabilities that were found, but we tell you if an exploit exists. And this is really big. You'll hear this debate a lot inside cybersecurity, which is, yeah, we found an exploit, but there's never been anyone to show that this vulnerability has actually ever been executed out in the wild. Well, in this case, we're showing you and helping you to be able to prioritize which ones to fix, because an exploit exists for this one. So let's do the drop down here. And we see that this is in zlib. This is a great example. And it was resolved 2 years ago, although it existed over 19 years. That's kind of scary. It's a buffer overflow. And zlib is one of those down in the weeds, open source components that's down inside that installer pretty deep. How are you going to know that unless you actually analyze this binary and go take a look? And if we kept going, we can see that there are many more here, and they continue to go down, obviously, in criticality. As we keep going further down, they get lower and lower in how critical they are and need to be fixed. Let's jump over here to, we've talked about SBOM a lot. So let's talk about here. You see we have bill of materials. So if we click on that, we're going to see here now that we are in the bill of materials. We're going to be able to look at different publishers here. So as we go through the components, we can see product names, version numbers, publishers, if we know, if that was available in the metadata as we scanned, and then the file names where we found these things at. If you click on publishers here, then you're able to see all the different publishers that are found inside, which is very interesting to me. These are all, and you know, we talked about open source software, but also, you know, commercial software. Remember, we said that commercial software is software that you pay somebody to be able to put into your code. And obviously they've been doing that because these are not just open source projects, these are people. And you can see they even have websites here where you could go, and I'm sure they have paid for the use of their commercial software inside their commercial software. But then we see other things too, Fedora. So that would be an open source. You see Red Hat in here, Splunk themselves, because again, that's the proprietary software we talked about, the Apache Foundation, unknown publisher. That again is always scary. And then we have all components over here. So you're able to really get in the weeds on your SBOM. You're able to search across the SBOM, and you can use regex to be able to see if certain components exist. That's that use case we were talking about earlier. If you had, if there was a large scale supply chain attack that came out and you needed to check and see very quickly if software had it, you can use this regex to search for yourself, but we also should be alerting you as well back on that summary screen as soon as we are able to put it into our system. Those are all the total issues right there that were found. The vulnerabilities we've already looked at. We have secrets. Now it says 42 secrets, but you can see also that these pass. A lot of these end up being placeholders. See, it says like put your password here, but it's just going to make sure that it alerts you every place that it sees that there could be a password or something like that. So you can see here, Joe password proxy example. And so we tell you like, hey, this is fine. It's not a problem, but we just want you to know that that is inside here. Sometimes public keys for repos to make sure that they're verified, to verify that you know, you pulled from the correct place and you didn't pull from the wrong place. Those kind of public keys will be in here as well. Behaviors. Let's talk about behaviors for a second, because this is something that I feel like is really unique to ReversingLabs. So when we talk about behaviors, what we mean is this is not part of the SBOM. This is things we found in the components, but we look at this binary and we see here that there's a behavior. And if we open this behavior, it says, look, this file, this behavior we've seen converts binary data into its stringed representation, which is commonly used in obfuscation. Now, that doesn't mean that that is what is happening right now. What it means is that this is a behavior that could be bad, that we need to at least point out and say, hey, this is the thing. And not only do we do that, but we show you all the files that we've observed using that behavior. Now, in this case, we don't have any here that that we're really throwing up and saying this is terrible, but we are trying to just show you that that behavior exists here in the binary. Now, for an installer like this, you would expect this. You would expect this, you know, the binary data to be converted into a string because you're installing things, and so it would need to do it. If you have a much smaller binary, that would be something that maybe you wonder why it's doing it. The other thing is when you go from one version to another. So maybe you've had several versions of a piece of software and it's never had this behavior before. And now all of a sudden in version 3.57, this new behavior is introduced into the binary. And you as a third-party risk manager, as someone who's doing application security, notice that this new behavior has appeared inside the binary. And that's the time to ask the question of the vendor, why did that get added? Why did we need that in the new version? What feature is that associated with? A lot of times with supply chain attacks, they sneak in because people aren't looking. No one is checking from one version to the next to see what the changes are. And no one is asking the question, hey, why did that change? That is how we're able to protect ourselves. We're able to look at that software from one version to the next and be able to know what those changes are. And I'll show you an example of that here in just a moment. Let's keep moving though before I run out of time here. And the next one is going to be network. So when we scan the binary, we're also looking for any kind of network, possible network connection we see. So an HTTPS that it's trying to reach out to, emails, any kind of URL that we find, we're going to pull it out and we're going to put it here so you can take a look at it and you can try to see if this, it seems legitimate, why it would be in there. This becomes really important if you have a piece of malware that's trying to talk out to a command and control server because they're trying to hide that in there somewhere. But we're scanning and looking for that. And of course, if we find something that's a known bad, we're going to alert you about that. File statistics, this is always crazy to look at, especially this is an installer, so it's very busy. But we're able to break down that binary into all the different pieces we see. And it is really crazy to see all the things that still exist out there in the wild. If I keep going down here, if you know some of these languages, Lisp has been around forever. Erlang, some of these are more obscure programming languages, Lua, Objective-C. I've still yet to figure out why Objective-C is in a Linux installer, because that's usually Objective-C is usually on a Mac. But Python, Puppet, lots of things are here inside this installer. So it's kind of nice. And again, if it's a smaller one, which we'll go ahead and switch now and look at one of the smaller packages, this becomes not so busy and easier to read. All right, so very quickly here, let me show you a couple more things, and then I'll open it up for any questions you have. Also, we have projects. So if you create a project, you get a piece of software. Now you can begin to keep this project and you can start scanning it from one version to the next. And so in this case, this is just the little XZ utils program, that repo that was in the news recently because of the XZ supply chain attack. And so our threat researchers put together here, these are some good versions leading up to the bad version that was out there in the wild and was luckily found before it really got wide-scale distribution. And then the bad guys took out the bad stuff for a version and then put it right back in. I think they were testing something. But let's look at right here. And now you can see exactly what I'm talking about. What this is, I'll close it again. We had the good version here, 5.4.6-3. And then we have 5.6-0.1. And when we open it, we get the comparison between these two versions. And you can see just at a glance, without even going super deep into this, you're able to see that the software quality has worsened. There's now a vulnerability. There's tampering now. There's malware. This is what I'm talking about. If you're trying to assess third-party risk from software, and even things you just use in your environment currently, this allows you to look at the versions and the updates as they come out and allows you to be able to make educated decisions about whether you're going to deploy that update or not. So there is that. And I was trying to think, oh, the last thing I was going to show you. So if we click on, let's click on this very top one here. And so now we have XZ. And let's say that we want to do that shareable report we talked about earlier. So right now we have no link. If we wanted to, we could just export. We could download the package again, by the way. That's one of the things. You could download the package back from the console back down if you needed to do further analysis on it. You can also export different types of SBOMs like the Cyclone XD. These are different reports. The ReversingLabs CVE report. This is another type of SBOM report here. And you could export those individually. Or you could click regenerate link, because we already had one, but it expired. You can set an expiration date on the link. You can say what you want. So I just want the Cyclone and the CVE. That's all I want. And we'll protect it with an auto-generated password. And I don't want to enable the package download. And we'll hit next step. Link will expire in 30 days. Download's disabled. It's just reviewing all these things. We generate a link. And now there we go. We've got a link that we can give to the vendor. Maybe we need to send it to a different security team. We can copy this password. And so even if they go to this link, they can't get into the link without the password. And they would be able to look at this would be a read-only shareable report that they would be able to look at. So there are shareable reports to be able to share out either to vendors or just within your organization. And I'm actually going to hit stop sharing so that we can take that back. All right, let me head back over here. Any questions as I keep coming down the home stretch here? Just put them in that Zoom QA if you've got any. And while we're waiting for those to come in, oh, all right. Okay. Let me read the question here, and let's see. So because of NDL or for other reasons, we can't provide the binary or information about it to a third-party analyst. Can Spectra Assure be installed and used on-premise? Absolutely. And air-gapped? Yes. Thank you so much for asking that question. I'm sorry I did not bring that up. We can absolutely install this on-premise, and you can absolutely keep everything in-house and have it in an air-gapped environment. So that is a wonderful question. Thank you so much for helping me to remember that I need to talk about that. And we do. We have several organizations that use us on premise, and we understand that you can't put that out for any reason. So yes, we provide that. Sometimes parts of a binary are obfuscated and encrypted. Supposing we are legitimate users, we possess license key dongles that allow us to use the binary under questions. Would Spectra be capable of performing the analysis? So if it's a known obfuscation, we can do it. And our team is constantly updating the core with any kind of obfuscation techniques that they find, so that and able to identify them the best we can, so that we de-obfuscate as part of the process. So definitely de-obfuscation is part of the process. Obviously, there are novel ones that are coming out all the time. And in the case I think you're talking about here, if there's something that's almost like commercial or proprietary, we would have to have a talk about it. We can talk with someone who's smarter than I am, and you can give your exact use case. But for anything that's known out there in the wild, once a threat researcher has been able to look at it, yes, they add it into the core. And that's actually part of the step-by-step process. I didn't get into that because I didn't want to bore everybody, but when we take the binary, and then the very first thing we have to do is find out what it actually is, because you can't believe file extensions. It's going to lie and say it's a PNG, but actually it's not. So first we identify that file type, then we look for all the obfuscation, then we de-obfuscate anything we can possibly de-obfuscate as we continually recursively go down. So yeah, thank you for those questions. Those are great. Anybody else has any, go ahead and ask. I'm just going to keep rolling here, though, before we run completely out of time. So we've got a couple more webinars coming around the corner. Next Monday, July 11th, we are excited to have Casey Crosley, the VP of SSCS, to join us to discuss her new book on end-to-end software supply chain security. You can get an overview of great product advancements from last quarter, as well as a sneak peek of what is coming up for RL in the quarterly product review roadmap for Q2. That'll be on July 17th, so tune in for that one. And then hear directly from some of our RL threat research team about open source threats they have recently uncovered. That's on July 18th. That's got quite the crew. That's a star-studded cast there that you'd want to see. And then we got another great speaker joining us on July 24th. Steve, he's the Director of Product Security at ServiceNow and the chair of the Cyclone DX SBOM Standard Working Group. That's a mouthful. So again, those are coming up. Make sure that you have also signed up for those as well. And there will be a survey coming up for you to fill out about that you were here and that we can prove you were here for those continuing credits, and that'll be coming out. So thank you for coming, everybody.